Okay, we are doing starting 3.2, which is complex numbers. Okay. Starting off here, all I want you to find is the square roots of these numbers. Okay, the square root of 4 is equal to what? 2. The square root of 16 is equal to 4. And the square root of 18, there's no perfect number that goes in there. It's just a little above 4. So we're going to break this down. We're going to say, what perfect square goes into 18? And what do I mean by a perfect square? Well, perfect squares are 1, 4, 9, 16, 25. Because if you took the square root of any of those numbers, you get a whole number. So which of these goes into 18? 9. So we can say the square root of 18 is equal to the square root of 9 times the square root of 2. And what's the square root of 9? It's equal to 3 times, not the square root of 3, sorry. 3 times the square root of 2. Good. You may be screaming, Mr. Higgs, why isn't it positive and negative? Why aren't these answers up here? Like the square root of 4, why isn't it positive and negative 2? Well, it's because really a simple answer there is we don't really have an equation. And we're not working with x, we're just working with the square root. And the difference there is, if I just took the square root of 4, and I took that on a graph, it looked something like this. That's what our graph would be. Okay, and then there becomes this whole discussion of, is this a function? Well, if we took the negative square root, we'd have something like this, and therefore this would not be a function because it doesn't pass the vertical line test. Okay, that might be a little beyond us right now. Simply put, because there's no x attached to it, or we're not solving an equation, we're just looking for the square root of that number. It's just the positive. 2 and 4 up there. So, now we're going to be getting into the lesson here. Last week in 3.1, we were told we can't take the square root of a negative. Well, I lied to you. We actually can. We can actually break this down here. And the square root of negative 4. We could say this is the square root of 4 times the square root of negative 1. Okay, we all know the square root of 4, right? That's 2. 2 times the square root of negative 1. The square root of negative 1, we call that I. That's an imaginary number. The square root of negative 1 is always I. We label it I, imaginary, I. And if we can't take normally we can't take the square root of a negative. Well, we can, it's just with an imaginary number. Okay, just like this one, square root of negative 16. That's like saying the square root of 16 times the square root of negative 1. Well, the square root of 16 is 4. The square root of negative 1, that's just I. And then the square root of negative 18. Well, again, which of the perfect squares goes in there? We know that can be used as the square root of 9 times the square root of 2 times the square root of negative 1, right? Because it's negative. Well, we have the square root of 9, which is 3, times the square root of 2 times I. We have to write this in standard form. We always have to write this in standard form. Our square roots go last. Our whole numbers go up front, so it's 3i times the square root of 2. That's our actual answer. Okay, and I think I have a little bit more down here. Yes. The square root of 32. I want to practice one more of these. Okay, one of the perfect squares goes into 32. We know 1 does, that's easy. 4, what else? 4, 9, 16, 25. Which of these goes into 32? Well, we know 4 does. But there's actually one bigger, 16. 16. So square root of 32, negative 32, we could say the square root of 16, and the square root of 2, times the square root of negative 1. Well, square root of 16, that's 4. Negative 1, that's I, times the square root of 2. Good. Okay, next it says find the values of x and y that satisfy the equation. Okay, so now we have x, 3x equals 12. We want to solve for x. How do we solve for x? Divide by 3 on both sides. We're left with x is equal to 4. Easy enough. This one over here, how do we solve for y? Well, we divide by 5 on both sides. We're left with y is equal to 25 divided by 5, which is 5. Okay. We want to solve for y in this instance. 3y times I is equal to 12i. Well, how do I get y by itself over on the left side? Well, we always do the inverse. We always do the opposite of what's happening, right? It's 3 times y and y times I. What's the opposite of times? Divide. Divide by 3i on both sides. Okay. Here the 3's and the i's cancel. Here's the i's cancel. So we're left with y is equal to 12 divided by 3, which is 4. Okay, this one may be a little confusing. Okay, because we have x, I, and y. Here's my tip. Here's how we solve these. Break this down into 2 different equations. Take your imaginary numbers. Take the things that are associated with that imaginary number and create your own equation off to the side. We can say 4i is equal to y times I. And then take your others, your real numbers, 2x and 10. Okay, and now solve both of these. What does x equal? Well, if we divide by 2, we're left with x equals 5. And over here, how do we solve for y? Well, we have to divide by I. So y is equal to 4. Okay, same thing on this one. Same thing. Set it up into 2 different equations. Take your i's. We have negative 3yi and we have 6i. Break that off. We have negative 3y times I is equal to 6i. And then we have 14x and 28. Solve for x over here. How do we solve? We divide by 14. We're left with x equals 2. Over here, divide by negative 3i. Because the negative 3's cancel, the i's cancel, we're left with y. Over here, the i's cancel. What's 6 divided by negative 3? Negative 2. Okay, same thing. Same thing. Get a little repetitive here. 22 and negative 11x. So 22 equals negative 11x. Over here, positive 6y and 2i. 6yi is equal to 2i. Okay, solve for x. Divide by negative 11. We're left with x is equal to negative 2. Over here, divide by 6i The i's cancel, 6's cancel. Okay, so we're left with y is equal to, what's 2 divided by 3? 1/3. And finally, last one. Break it down. 5yi is equal to 5i. And negative 12x is equal to 36. Divide by negative 12 on both sides. You should get x is equal to negative 3. And divide by 5i. Okay, here y is equal to, the i's cancel, the 5's cancel. What is anything divided by itself? 1. Okay. Next, we're going to add or subtract and write our answer in standard form. Okay, add or subtract. This is just like PEMDAS. Parentheses, then exponents, then multiply, divide, add, subtract. Okay, parentheses. Start there. Can we do anything inside the parentheses? 3 plus x, 5 plus 2x? No, they're not like terms. Can't do anything in there. There's no exponents. There's no multiplication or division. So we're just going to add. We're just going to add these. Right? Add your like terms. We have 3 and 5. So 3 plus 5 is 8. Plus x and 2x would be 3x. Hey, this one. We have 5x minus 3 minus x minus 2. Okay, start with parentheses. Can you do anything in there? Nope, no like terms. There's no exponents. Multiply, divide. Have to be careful. Have to be careful because of this right here in the middle, and that's a minus. That minus 1 is being multiplied to both the x and the negative 2. Okay, so you can actually rewrite this. It's 5x minus 3 plus, what's negative 1 times x? Negative x. And what's negative 1 times a negative 2? Positive 2. And now we can take our like terms and add them. We have 5x and negative x. That gives me 4x. We have negative 3 and positive 2. That gets me a negative 1. 4x minus 1. There's our final answer. Same thing goes with i's. We can't add anything together unless they're like terms. Well, if they have an I with them, they're a like term. Okay, so here we have a plus, so we can just add right across. 5 and 3, that gets me 8. Negative 2i and 5i, that gets me positive 3i. Okay, and another example here. Got to be careful. Got to be careful because we have this negative, right? That negative distributes to both of these. We're left with 4i minus 6 minus 3i minus 6. Like terms, 4i, negative 3i, that gets me 1i, so it's I. And then negative 6 minus 6, that's negative 12. Oh shoot! Got to write it in like standard form, right? Standard form. Standard form has the I. I always trails. Okay, we always write our whole number first and then I. So this in standard form would be negative 12 plus I. I always comes last. Let's see if I made that mistake up here. No. And with I always trails. I always trails. Okay? Okay, that's it.